Welcome to the video on distance versus displacement. First of all, hopefully by now you have looked at the PowerPoint presentation and you've seen that you have this equation, which is the equation for figuring out displacement. You've also looked at the difference between position and distance and displacement. And that's what we're going to talk about right now. So I have drawn this wonderful picture of a house, I don't know what that is, a mall, and an apartment building. Now, when we talk about position, if these are all in kilometers, then the position of the house is at 0 kilometers. The position of the mall is at 8 kilometers, and the position of the apartment building is 15 kilometers. That's the position. If we want to talk about it as a vector quantity, we could say that the mall is 8 kilometers to the east. Because if you remember, north is up and south is down, and to the east, that would be this way to the right, and west is to the left. When we're talking about something two-dimensional, like a map or like a vector in physics class. So the position of the house, 0 kilometers. The position of the mall, 8 kilometers, and the position of the apartment building, 15 kilometers. Now we're going to start talking about traveling back and forth, which are going to be distances and displacements. Let's say we start at our house, and we go from our house, which is at point A, and we go to point B, which is the mall. From there, we then decide to go from the mall back to our house. There's a difference between distance and displacement. Distance is going to be the total path covered. So if we go from our house to the mall, that's 8 kilometers. Then we turn around and we go back again, that's another 8 kilometers. So we have traveled 16 kilometers. If we talk about displacement though, the definition of displacement is taking where you end up minus where you started. Well, in this case, we're exactly where we started out. So the displacement for this trip, going from our house to the mall and back to our house again, the displacement is 0. So it's possible to cover a distance but still have a displacement of 0. That happens when we run track. If you start at the starting line and you end at the finish line, it's not a staggered start, your displacement is going to be 0 even though your distance is not. We can make this more complicated by saying, let's say we travel from our house at A to the apartment building, and then from the apartment building, we go back and we stop at the mall. Once again, distance and displacement are different. So for the distance, we started at our house, we went 15 kilometers to the apartment building, and then we turned around and went back 8 kilometers to the mall. The distance is the total path traveled. So this is going to be 23 kilometers. Distance is a scalar quantity, so therefore there's no direction that goes with that. So 23 kilometers is going to be your answer for the total distance covered. 15 to the apartment building, and then 8 more back. 15 plus 8 is 23. Displacement is different. When we talk about displacement, we're talking about from where we started to where we finished. We started at our house and we ended up at the mall. That's a vector quantity. That's why I drew that as an arrow. So we've only gone 8 kilometers. Not only have we gone 8 kilometers, but because this is a vector quantity, we have to talk about a direction in which we walked. Well, the difference between where we started and when we ended up is 8 kilometers to the east. And so we show that. Distance and displacement are different.